Welcome back, everybody. Today we're going to do inverses, which is using the unit circle in reverse. But before we get to the details of the unit circle, let's go back over what an inverse actually is. So from the graph, you can tell if you have a function. If you pass, I'm going to call this function f of x, just to give it a name. So f of x is a function because it passes the vertical line test. So the vertical line test, if you recall, if you draw any vertical line, it's only allowed to touch the graph once. Now the symbol for inverse has the -1 as your power. So that would be the inverse of f of x. And you can tell if the inverse is a function by the horizontal line test. So if we draw any horizontal line, and if any of these lines touch the graph more than once, then it's not, the inverse is not a function. So the inverse of f of x is not a function because it failed the horizontal line test. And then this leads us to the trig functions. All right, so that's the background of a inverse, if that helps you. So here you have your cosine graph. And the cosine graph itself, if we use the vertical line test, is a function, right? So that's a yes. The inverse, however, right, that's not a very straight line, but you can see clearly that a horizontal line would touch that graph more than once. So the inverse is not a function. So we've got an issue. We have to restrict the domain to make it a function. So basically, if we cut this graph, right, at pi, then the values don't repeat, and if it now passes the horizontal line test. Well, if you restrict the domain, that impacts how you use the function. So our domain is now only 0 to pi. It can be 0, it can be pi. And then the actual way to find the inverse, and we're going to put all this together, if you recall, in order to find an inverse, you just switch x and y. So we're going to use our restricted domain, only from 0 to pi, and switching the x and y fact to create the graph of the inverse cosine. All right, so let's just come up with, we know cosine values. This is just the cosine of x. This is nothing fancy. This is just right off the unit circle. At 0, it's 1. At pi over 3, it's 1/2. At pi over 2, of course, the cosine is 0. At 2 pi over 3, the graph or the cosine is -1/2, and at pi it's -1. Now there's other values, but those are the ones that are easiest to graph. So if we want to graph the inverse, we just switch the x and y, or we read this thing backwards. So now we're going to plot the point 1, 0. So we're really graphing 1, 0. We're going to switch all these 1/2 pi over 3, because this is how you do an inverse. You switch the x and y. So we're going to go over here to 1, 0. We're going to graph 0.5 and then go up to pi over 3. And you can see that the angles are now on this axis because everything about x and y gets switched. How you label the axes, how you write the points. So it's very consistent. Everything gets switched. That's 0 pi over 2. Now we have on the negative side, -1/2 up to 2 pi over 3. And then, of course, -1 up to pi. So this is what the inverse cosine graph looks like, where the domain, so it goes from -1 to 1, and we know the range goes from 0 to pi. Now you don't have to know this graph. Oops, it goes like this. But you can see the graph is much different. And the important part is this. It's very, very, very restrictive. We're not going to do this with all of the functions, but basically this is why all of the functions have to be restricted, because of that horizontal. I think that sometimes it's easier to understand inverses on the unit circle. It's just a little bit easier to picture. And you're going to have the unit circle to look at. So we know that the inverse cosine is only allowed to go from 0 to pi. All right, so the inverse cosine can go from 0 to pi. So it goes first and second quadrants. It's not allowed in those other two quadrants. And so what that means is you're not allowed to land there. You're not allowed to pass through there. You can't use any angle. Like you couldn't say 11 pi over 6. You couldn't say negative 2 pi. You cannot basically spin down. So you're not allowed in or through these two quadrants. Sine and tangent, as weird as this is, they are the same. So we know tangent, and we'll start with tangent. Tangent has that asymptote right here where it's undefined. And so tangent, inverse tangent rather, is not allowed in these two quadrants. So you think of it as 0 up or 0 down. So we don't call that 3 pi over 2. We call this negative pi over 2 or negative 90. And of course this is pi over 2. And when we do some problems, I'll show you how this works. So the tangent is positive here and the tangent is negative here. So we do get the positive and negative. The cosine is positive here and negative in the second quadrant. Now for sine is weird because sine is positive here and here. So we can't do it like cosine. Sine is negative down here and here. So for sine, we treat it like tangent. So the inverse sine is only allowed to go 0 up to pi over 2 or 0 down to negative pi over 2. So sine and tangent have the same restrictions. And we'll do some problems here in a second. So in order to find an inverse, to go back to our switching x and y, we know we would switch the x and y. So we would get x equals the sine of y. Well, in order to solve for y, you have to use the inverse. There is no dividing by the word sine. There's no radical sign. How do you get rid of the word sine? Is you multiply it by its inverse. So if we multiply both sides by the inverse, the word sine and the inverse cancel each other out, and now we have the inverse sine of x equals y. If you recall on your calculator, anytime you hit second, whether you hit sine or cosine, right, it shows up like this on your calculator. So inverse functions are used to find angles. And that's an important thing to realize. We've already done it on the calculator, but sometimes when you look at the unit circle, it gets a little bit more confusing. So let's try some of these. Also in this box, you can see we have other names. Sometimes they use this little ARC prefix instead of the -1 power. It means the exact same thing. It means basically find the angle. So you'll see both kind of used equally. So underneath here, let's actually go to the unit circle. So if you have a unit circle to look at, that might be helpful. So the question right here, I think this is a good one. This is what you want to ask yourself. Where is whatever happening? So where on the unit circle does the sine equal radical 2 over 2? Now remember, sine is only allowed to go here or here. You're not allowed in these two quadrants. So that is at pi over 4. Where does the sine for number 2 equal -1/2? Well, in this quadrant, sine is positive. We're not allowed to do this. So you're basically not allowed to go all the way around. You just have to go from 0 up or from 0 down. So sine is negative. It's really 11 pi over 6 if you're looking at the unit circle, but we're not allowed to use that name. So we have to call this negative pi over 6 because we went down pi over 6. Where does the cosine equal negative radical 2 over 2? Well, cosine is different. Cosine is not allowed here and here. So cosine's negative over here. So we look at that quadrant on the unit circle, and that would be 3 pi over 4. Where does the cosine equal -1? Well, if you think about your quadrantals, right, cosine is allowed to be here, it's allowed to be here, and it's allowed to be over here. So we're not allowed here or here, right? So the cosine is -1 right there, which is pi. Or does the tangent equal radical 3 over 3? Now, when there's two 3's, you know there's a 6 in the denominator of your radian measure. So this would just be pi over 6 because it's positive, so it's easy. Tangent is 0 where it's flat, right? So this is a 0 slope. And remember, you're only allowed to go 0 up, 0 down. You're not allowed to say 2 pi. So you have to just say 0. And where does the tangent equal -1? Well, unlike sine and cosine, which up here, right, these are your sine and cosine ones and negative ones, tangent's 1 at pi over 4. So we have to, again, negative, we're only allowed here or here, so we have to spin down, which we'll call negative pi over 4. So try the problems to see how you do, and we'll go through any questions that you have or any issues, any things that you're unable to figure out. We'll go through those in class.